All right, we're going to begin talking about engine measurement tools, and I've given each of you this sheet that shows a picture of different measurement tools. We'll talk about them one at a time. We'll talk about calipers first, and I don't know if I held it up straight, but there it is straight now. So we'll talk about and get a good look at this so you can kind of see what I'm talking about. We'll talk about each of these tools and go through them, and we'll show some things down here on the bench. So we're going to talk first about dial calipers. So these are dial calipers, and these are inch standard dial calipers. Dial calipers can do three things. So three things they can do. So the first thing they can do is measure outside diameters of devices. So for example, here I'm showing you, I can measure the outside diameter of this wrist pin with these guys. So you see that? I'm not going to talk to you so much about reading the scale, a little bit. But basically what it is this scale has tenths of an inch on the beam here. So right here, you've got tenths of an inch on the beam. And then one full sweep of this wheel is a tenth of an inch. Okay, is a tenth of an inch. So for example, when I go ahead and measure this, I'll move these like this to make sure I'm at the smallest spot. Does that make sense? And it's flat. It's grabbing the wrist pin flat. And I'm reading 0.870. So I'll show you the dimension first for the camera, and then I'll pass it around to the rest of you. You can see it's 0.8 here on the beam, and then 70 on there. So see 0.8 on the beam, that's 8/10 of an inch, and then 70 thousandths on the dial. So that's 0.870 inches. So it's just under 900 thousandths of an inch. 1 second. So as I said, I can measure three things. I can go the outside diameter of this camshaft journal. What about this cam lobe? I can measure, and we're talking about measurement, but I'm also talking about camshaft terminology. This is called the base circle of the camshaft. That is where it's not on the lobe. And this one's measuring, the base circle is measuring 1.180. And then I can go over here and find, notice the dial moving like that? You see it moving? So I can find the peak of the lobe right there by going like that, back and forth. And you can see there it's smaller, bigger, then smaller again. So I'm getting about 1.450. So I take 1.450 and I subtract 1.180, and I get the net cam lift. So I can actually measure the lift of the lobe with a pair of dial calipers. Dial calipers like this are accurate to about 1,000th of an inch. The smallest scale on there, each one of those little lines there is 1,000th of an inch, so you guys can see that. Can I estimate maybe halfway between? Yeah, I can estimate, but it's not really accurate. If I push, depending on how hard I push on this thumb wheel like this, I can actually flex these out. That would be inaccurate, right? So a lot of these will have a thumb wheel that when it hits, it just keeps, some of them will hit and it'll just keep rolling. See how it keeps rolling? Watch. So I can still push the thumb wheel. It keeps rolling, but it doesn't go any further. In my opinion, that's a little bit too tight, so I just get very gently on there, get it like that, and I can measure outside diameters of things. The other thing the dial calipers can do is measure inside diameters of things. So like this, I can measure the inside diameter of this pin with these guys right here. So this is the inside diameter here. And I'm still measuring on the beam, and this one is measuring 0.537. So 0.537 on the caliper. So I'm reading 5/10 here on the beam, and then 37 thousandths on the wheel. So 0.537. So outside diameters, inside diameters, and then the third thing is I can measure depth. Let's say I want to know how far the surface of this bearing is off the table. This part of the dial caliper measures depth. So I can go down here, touch there, and I get, on the beam, I got 2 inches plus 94 thousandths. So that's 2.094 inches. Try it way up there and see if the camera can actually see it. There it is, 2.094 inches. So you guys can see the 2 inches on there, and then see the 0.94 on the wheel. Again, Each one of these little lines is 1/10 of an inch, and one sweep of the wheel 360 degrees is 1/10 of an inch, and the smallest line on there is 1/1000th of an inch. Notice when you look up at the caliper, right in the center of the dial itself, see if you can see it there. If it'll focus on it, which I don't think it's going to, let me try it like this. If it'll focus on it, it says right in the center here, it says 0.001 inches. Do you see it right there? 0.001. So what does that tell you? That means the smallest dimension it measures is 1/1000th of an inch. So just for kicks, let's see what this does. If I close this all the way up, okay, it's within, I can adjust the wheel slightly. It's within, okay, I've got the wheel adjusted right on 0. So somebody give me a hair from your head, whoever wants to. Want to give me one? Whoa! Look at all those hairs. Wow. Okay. So let's see if we can actually measure. Do I have one in there? No, I didn't get one in there, did I? Now I'm all tangled.
He's gonna keep it.
Wow. Am I gonna get COVID from this? Just kidding.
In this pocket.
Okay, so it's measuring about 2/1000ths of an inch. You can see it there on that hair. Your hair looks fairly coarse. Did you get one out? Yeah, you can. Hers is blonde. It'll probably be pretty fine. I expect it to be about 1.5 thou, just from years of measuring.
It's fine hair, about 1,000.
Okay. And then, by the way, we're going to see what this one, let me just check it, make sure it's zeroing. Yeah, it's within 1/4 of a thousandths. So I'm trying to get it right where I can measure it. It's thin enough that it's hard to see. Okay, yeah, just like I thought, about 1.5 thou. So it was within, it wasn't zeroing, it was about a half. So hers is married. Blonde hair, female hair typically measures about 1.5 thou thick. So guys' hair that's black or red will be like 2.5 thou. Yours is probably, can I get one?
Yeah.
Come on, give me one. You got coarse hair too, Chase. I bet yours like 2.5 thousandths.
Well, mine.
Yours is kind of a little coarse too. Maybe not as much as his. Anyways, so you guys, dial calipers. So can you see that this is a really great, useful tool? It really is. So again, outside diameters, inside diameters, depths. This is like a go-to in a machine shop. Is it super accurate? No. 1/1000th of an inch, that's decently accurate. In a machine shop, that's not super accurate. With an outside micrometer like this, I can take an outside micrometer and I'll be accurate with this outside micrometer. Many of these will allow me to get down to 1/2 or even 1/4 of a thousandth. They say, please don't move that because it's going to move. The camera's on this, so don't move this card. But they say that this is accurate to 1/1000th, but it's actually accurate. We use them down to 1/4 of a thousandth. We'll estimate to 1/4 of a thousandth. So the next thing on your sheet is a straight edge. So I want to show you a straight edge and what we can use it for. Before I go to the straight edge, here's a steel rule. And this one's down to 1/8 inch on the, do I have it right side up? So it's 1/16 on the bottom and it's 1/8 inch on the top. So that's a steel rule, real accurate steel ruler. On the back, this one has 64ths on the bottom. It goes to 64th of an inch on the bottom, and on the top it's 32nds. So you see how, I'll pass that around, you can kind of check that out. And also I'll pass this dial caliper around so you guys can kind of check it out. Please, on the dial calipers, don't tighten it real tight because you can actually bend the fingers. One other one I want to show you, this is a metric dial caliper. So this one measures down to, I believe it's a 0.05 millimeters is what it says there right on the screen. It's 0.05 millimeters. So each one of these on the beam is 1 millimeter. Does anybody know what's a millimeter in terms of inches? How many?
Like 2.5 to 3 centimeters.
Yeah, it's actually I'm pretty sure it's 2.54 centimeters per inch. So that's 25.4 millimeters per inch. So in thousandths, about 40 thousandths per millimeter. Did I do that right? Maybe I didn't do that right. Yeah, so it's 40 thousandths per millimeter. So there's 25.4 millimeters an inch. So if you take 25.4 times 0.04, you should come up with 1 inch. All right. So next, what we're doing is a straight edge. Okay, so what we're going to do is you're going to use a straight edge, precision straight edge, to measure flatness of the cylinder head. If I sight this straight edge this way, looking down it like this, it's not straight. It's curved a little bit like this, doesn't matter. If I sight it like this way, this thing might be a little, it's not straight, doesn't matter. The straight edge is straight on the edge. Straight edge, makes sense. Okay, it's straight on the edge, right? And on one side of this, I have a little bit of a burr. Let me just see where it is. Okay, this side's clean. I got a little bit of a burr right there. Okay, a little bit of a ding. And that ding will throw me off. It's right there. There's a little bit of a ding right there where my finger is. I could take what's called a draw file, just has a single cut mill file. Sorry, it's a single cut mill file, and I draw a file, which means when you take the file like this straight across and just pull it and push it back and forth, it would take that burr right off. I got to be real careful. I would actually not want to do it on this surface here because I could actually lower that. I just put it on the edge and just get the burr off the edge. So here's how I'm going to use it. I'm going to put it across the cylinder head like this. First, I want to see if the cylinder head's warped anyway. Usually if it's warped, the center tends to suck up like that. So I'm going to take a feeler gauge that's only 1/1000 thick, and it's got a measurement on there, and I will find it and then show it to you guys. There it is, right in the middle there. It says 1/1000 right there, and so that one says 1/1000. You can pass it around. So what I'm going to do is I'm going to put the straight edge like this, and I'm going to see if I can move this out. So what I'm looking for is if the feeler gauge comes through without dragging the straight edge, it's warped more than the thickness of this. With these 1/1000 ones, I can fold them over like this, put the straight edge down like that, and then it's still, it comes out. So this is warped more than 3. Hold that. So now what I'm going to do is I'm going to grab, there's a 2/1000, a 3/1000, here's a 4/1000 feeler gauge. I'm going to take my straight edge.
When the thickness of that metal is
1/4,000 of an inch. Okay, so and I'll prove it to you in just a second. So if I put it under here, it's still not dragging the straight edge. If I put it over here, it's still not dragging. This head is warped more than 4/1000 of an inch. Let's keep going. Let's go on up, let's just accelerate here and go up to 8/1000 of an inch. And I'll put my straight edge down. And now it started to drag the straight edge. You guys see it? So when I put the straight edge there, it's pulling the straight edge, but barely pulling it. So I'm going to go to 9 and do what I call a go, no-go test. In other words, if I think it's about 8, put in a 9. And if the 9 obviously drags, see, I'm just trying to see if I have a 9. I don't think I do. Okay, let me measure how thick this one is. I can't see a measure. Oh, wait, there it is. I think that's a 7. So I could take my dial calipers.
Are you able to add like a 4 and a 5?
So I'm going to try a 10,000th. And I'm going to put my straight edge on here. And it's dragging the straight edge. It's dragging the straight edge. It's dragging the straight edge. So that means it's warped less than the thickness of this. I'm going to try an 8. I think I get down to an 8. Let's see if I can. Sorry, I tried an 8, didn't I? Let me see if I got a 7. That was the one I had just a moment ago. 3, 4. Okay, this one is a 7. So I'll put the 7 on here, and the 7 definitely pulls out. So we're going to call this cylinder head, we're going to say on the ends it starts to pull it there. Over here, It's starting to pull it there, but on the 8, it was kind of slipping through and kind of dragging it. This cylinder head's worked, 8 thousandths of an inch. Totally unacceptable. Normal spec for warpage on a cylinder head is we want it to be under 2. So 1.5 is acceptable, 2 is not acceptable.
Does that mean it's like dunzo?
It means it needs to be surfaced. So right now, this cylinder head is like, it's worn like this. It's about 8 in here, it's about 7 in here, probably less out here. So this surface needs to be surfaced. The way we do that, we'd have to remove this dowel, take the machine shop, they would machine it. Couple of problems when you machine a cylinder head. Think about it. You machine a cylinder head, now the distance of the cam towards the crankshaft is a little bit closer. But if you got a timing belt with a tensioner or a drive chain with a tensioner, it's okay. What also happens when the bottom of the cylinder head wears or gets warped? Sometimes these warp. Let's see if I can detect any warp. Oh yeah, I can. I think I can. Let me just see. Listen. You can actually hear it. So these cam saddles are not straight. They're actually warped. Now, what my experience has been in the machine shop world is that these saddles here, when they're warped in here between these, what we typically do, there's a way to straighten the head, but usually we don't do it. We'll machine it, we'll bolt the cam in with lubricant, torque the caps, and if the cam spins freely by hand, we just run with it. The cam, you do have, so what I'm saying to you is, while it's not really accurate to do that way, it works, okay? And sometimes we have to say, well, maybe the engine or the car is not worth that much. Is it really worth putting all the expense to get it 100% true? No, maybe it's not worth it so much. So we're going to go ahead and do what we have to do within the budget that we have. So next we're going to be looking at outside micrometers, and this set that I have here is inch standard outside micrometers. First thing to note on an outside micrometer is that all outside micrometers measure a span of 1 inch. We're talking about inch standard ones. They measure a span of 1 inch. This one says MIC 01. It measures from 0 to 1 inches. So if I close this up, and the fastest way to close it is to roll it on your arm. I can do it like that. Roll it on your arm like that. And I get it closed up, and it is right on 0, 0 on the thimble there. Let's see. Yep, I can read it there, 0, 0. So I'm going to, and this thing has a friction clutch on the back. And what that does, it tries to help me from tightening things too tight. So let's say I want to measure this valve stem. I'll go like this, put it between here, roll it between my fingers, and I just very gently do this, or I can use this friction clutch. And it's measuring on the screen. If I can hold it up there. It's measuring on the screen 0.216. So this is 0.216 inches. So we'll talk a little bit more about how to read the outside micrometer, and I'll give you guys a sheet. But basically, on the beam, we have tenths of an inch right here. And then between those tenths of an inch, we have 25 thousandths. So there's 4 division lines. So when you guys look at it, there's tenths of an inch here. In between, there's 4 lines. And one sweep of this wheel all the way around is 25 thousandths. So there's 4 25 thousandths marks to go from 0 to 1 or from 1 to 2. We'll talk about that a little bit more. So this is really accurate, and some of them will actually read, like this one actually will read down to a 1/10,000th of an inch. You see these little numbers here. If I can hold it up so we'll actually focus on that. Those little numbers there are 1/10,000th of an inch. So I can look at this and measure this guy again, get him on that valve stem there, and he's measuring 0.216, and he's also measuring 0.216, and it's measuring, 0.2161. 0.2161. So I've got 1/10,000th of an inch
measuring down here, okay? So that's a 0 to 1. The purpose of these little standards here is to make sure this guy is in calibration. So I'm going to take a 3 to 4. I'm just going to look at the size of my guy here. I'm going to open this thing up. I just roll it on my arm really fast. This gives me a chance to measure very, very accurately. I can measure, for example, this piston skirt. So this is a 3 to 4, and it will measure this. Most pistons are measured about a ½ inch from the end of the skirt. And when I do this, I have to make sure that I'm getting the piston, the calipers in the center and right there. So I'm measuring about a ½ inch down from the tip of the skirt, and I'm right in the center. And this guy's measuring, it's a 3 to 4 inch mic, so it's 3 inches plus, I'm actually right at 4 inches plus 6½ thousandths. So if I pass this around to you guys, you'll see it's actually all the way out at what says 0. So that's 0 is 4 inches. I'm actually 6 thousandths over. So even though it's only supposed to measure from 3 to 4 inches, that caliper is giving me the opportunity to measure that with a 3 to 4 inch mic. I do have larger mics. Okay, so what I'm also going to show you here is here's a set of metric mics. This one measures from 0 to 25 millimeters. Well, 25 millimeters is right about 1 inch. So I can measure in metric. You guys, if you work in a machine shop, you have to be able to read an outside micrometer. We use them all day long. So when I was at Phil's machine back in the day, I would literally be measuring pistons every day. Okay, taking measurements, trying to figure out. I would be the guy who's deciding which piston we're going to sell to a customer. This is a race piston with a dome and 4 valve reliefs, actually 5 valve reliefs. And it's got a short skirt, on and on and on. So that's a metric micrometer there. So next on our list is, I mentioned we looked at feeler gauges. We used the feeler gauges here. Here's another set of feeler gauges. We use the feeler gauges for checking straightness, but we often use these to measure clearance for valve clearance. So if you look at these feeler gauges here, you can read what they are in thousandths and what they are in millimeters. And these can go between the top of the valve to check valve adjustment and a rocker, and we can slip this guy in here, and we still do on certain cars have to check valve adjustment. Okay, that 03 Toyota Tundra that was in here recently, I think it has a tight exhaust valve on cylinder 3. That's what I think. I'm going to try and verify it this weekend by driving it, see if I can set monitors or see if it wants to reset the check engine light. When I do compression test, it passes. Compression test isn't the most accurate thing in the world, neither is leakage. Why is that? Because they're not testing it dynamically when the engine's running. So when the engine's running, things happen so fast, it may not be closing enough to really seal compression. Does that make sense to you? So we'll measure with the valve clearance with a feeler gauge like this. All right, so next is the inside micrometer. Here's the inside micrometer set. So here's the body of the micrometer. This goes from 0 to 1 all the way up to, I got a 6 to 7. So if I had a hole that was very large that I had to measure, we could use that. I'm going to go down here to I'll go to like this is a 3 to 4 right here. When I put this guy in, that's a 3 to 4 inch beam. You guys can see it. It'll measure it from 3 inches out to 4 inches. So if I had a cylinder, like if I wanted to measure this one's like 2 inches, I could go down inside in there and measure this. I have to get it straight this way, like this, and I have to get it, so I get it straight like this, and I have to get it straight like this. And this is how we accurately measure the inside diameter of a cylinder. And then it has a scale on it, just like a regular outside micrometer. And you can see the tenths of an inch and the 25 thousandths and then the individual thousandths on the thimble. So in the machine shop world, you know what we usually do with these? We usually go down and get the measurement, and then we usually measure this with an outside micrometer for real careful accuracy. but this is to measure inside diameters of things. Okay, so to measure, like downstairs on that 1948 Oliver 60, we would take this to measure real accurately and find out what the absolute wear is. We would check the cylinder this way and then turn it 90 degrees to find out if it's out of round. Check it at the top, check it at the bottom, read how much taper, the difference in diameter from top to bottom is taper. Difference from here, 90 degrees, like this, you guys, there to there is what we call out of round. We can say the cylinder is egg-shaped. Okay, so that's an inside micrometer. Pull this guy out. Next is on your sheet is a snap gauge. This is a snap gauge. It's a spring-loaded little guy. So if I've got a small hole like this that I need to measure, I can go down. This is an inexpensive tool. I can go down inside here and get it straight down in there. And then I can go ahead and go up and down and then tighten it. Then I pull it out and then I measure it with my outside micrometer and I can find out the inside diameter. So this is an inexpensive way to look at inside diameter. It's called the snap gauge. Here's another gauge similar called a small hole gauge. This is for measuring a valve guide. I'm going to show you this. So I want to go down inside and measure the diameter, inside diameter of a valve guide. I can put the small hole gauge into this guy here. This one's too big. I need even smaller. And I'm going to put this guy down inside here. Try to. And collapse this down. Okay, so I put it inside there. I expand this out. Okay, so what I do is, as I tighten this, this splits the wedge on this little guy apart, and then I just measure the outside diameter with a micrometer. So can you guys see as I expands it, decreases it? And that's what we call a small hole gauge when we want to measure something like the inside of a valve guide. So both these tools, the snap gauge and the ball gauge, are used in machine shops for doing measurements, but they're not considered super accurate. So we have other ways of doing it. The inside micrometer is our super accurate way of measuring inside diameters. But when you get really small things, we've got a valve guide measurement tool that I'll show you in a moment. You guys, so this is a small dial bore gauge for valve guides. So what this does is I push this thing, these little wedges down here go in, and they read on this dial bore gauge. So I can slip this down. This has a setting fixture here. I put a couple valves in. I set this fixture so that when this needle is pointing to 0, I can set it for the exact size of the valve stem. And then I can see how much clearance we have. So for example, the average exhaust valve runs about 1.5 to 2 thousandths clearance, usually new. And an intake valve will run closer to 1 thousandths clearance. So after we measure valve guides, if we have to actually size them larger, this is a little tiny hone. You can see it's got a stone on there. We put this in a 3/8 drill and we spin this guy inside here, and I can change the tension, which moves the stone out and removes more material. Okay, next is a dial indicator. So I grabbed the dial bore gauge. Hang on one sec. Okay, so here's our dial indicators. This first one, which sweeps 100 thousandths on the face, 1 thousandth for each small division. You can see it says right there. This actually says 0.005. So the smallest lines on this, I'm sorry, are actually in between, are 0.5 thousandths or 5/10 thousandths. The way this one works, this guy's a magnet, so it can clamp onto this guy with a magnetic base, and I'll tighten this up. So that guy can sit there attached to this steel bearing, and I can move the plunger like this. I can put it against something, and as I move it, it sweeps the wheel. So I can go like this, as you guys can see, and sweep the wheel to check something. For example, I could take this dial indicator and put this magnetic base. So there, it doesn't, when I push the switch, it wants to sit on there. I could rearrange this, and I'm just going to hold it so you can see it, with the plunger against the rotor and spin the rotor and read how much run out I have around that. In other words, how much wobbling it gets. So this guy's going to move back and forth, and it's going to read how much in and out movement I have. So we'll put this on the front of a crankshaft, and we'll move the crankshaft in and out. We'll measure what we call end play. So as I was saying, I can use this plunger to measure a number of things. I can actually set this on top of a cylinder block, bring the piston up, and measure get the piston all the way to top dead center, and then use something called a depth mic. We'll look at just again to see how far in the hole the piston is, if I'm doing what's called a compression calibration. Okay. What this is this is a holding fixture for a dial indicator. So what I can do is I can mount this dial indicator on here like this. If I can unscrew that, get this guy up here. Should be able to. So now I've got this dial indicator set up on this vice grip fixture. And so what the idea is, I can clamp this to something. Oh, I don't know, can I clamp it to this table? We'll try. Hopefully. And probably do some damage to the table, which isn't smart. I can move this around and get this set up to go against something. I can lock it in place. So right now it's just out there in the air, but what I can do is I can come over here and I could go ahead and clamp this down here or up here and get this measuring rotor run out. Okay, I could clamp it over here and measure rotor run out. So this is a vice grip fixture for holding a dial indicator. That's what that guy is. Next, this is a depth mic. And what a depth mic is, just like all the other micrometers, it's got a regular micrometer scale, and I've got it upside down that reads in tenths of an inch and thousandths on the thimble that I'm turning. And what this is for is it's a measurement from the tip of this guy to this surface. So for example, there's an indent here, and if I want to find out how far down that is, and you're saying, why would you want to do that, Mr. O? Well, we measure pistons and things. We want to find out how far down the piston is in the hole. We can go this to the top and we can measure. It's a super accurate instrument. It measures again from the tip of this measurement point to this machine surface. Very, very accurate. So again, like let's say I want to measure how I can measure, well, how far is this dome on this piston above the top surface? Like how high is the dome? I'm going to do a compression calculation. I can start going down here, and I'd have to kind of hold it firmly. And that guy is a 0.215. So less than a quarter inch, but it's 0.215. See if I can get it to, actually that's not 215. There's 215 there. Right there is 215. Okay, so that's called a depth mic. So none of that fancy schmancy stuff. So here you guys go. Here's a dial bore gauge. It's our next tool. What a precision dial bore gauge does, it allows us to measure cylinder taper and cylinder size on an engine, for example. It has a little measurement point right there. I'm pushing with my thumb, and you can see the dial indicator moving. So we can put different tips on this guy for different size hole dimensions. We're going down inside a hole or a cylinder, and we can set this in a setting fixture like this. We can set this to a certain dimension here. So we're zeroing out the meter at the size of the cylinder. We put it down in, and as we go up, we can see if there's more wear. We can measure taper. Taper is wear in the cylinder as you go up to the top. Really, really nice instrument called the dial bore gauge. We bought this one a couple of years ago because of the Skills USA National Contest. You have to be able to use one of these. You have to use a lot of these tools in one of the stations, and you have to be able to know how to read it and how to set it up really, really quick. So this is a very nice tool, again, for putting down inside a cylinder and measuring cylinder wear. All right, so for example, is the cylinder smaller at the bottom than it is at the top? That means we have some taper. So at the bottom of the cylinder where the piston doesn't wear the cylinder, that'll be your standard factory size. As you go up to the top of the dial bore gauge, if you read like 3 thousandths clearance at the top, or more wear, I should say, not clearance, but more wear, then we've got 0.003 of an inch taper. If I go in this direction and I turn it 90 degrees, I can measure out of round, right? In other words, is the cylinder egg shape or is it round? It's supposed to be round. One of the things that's kind of interesting to talk about that's a little bit off topic, and that is that when you go ahead and build an engine for a race car, one of the things that we do is that you can imagine when we torque a cylinder head down on a block, well, the bolts stress it. So the cylinder head getting clamped onto a cylinder, the cylinder actually distorts. So when for a race car, we do stuff like in the machine shop, we have a torque plate. It looks like it's like a 2-inch thick steel plate with the holes for the cylinders. We bolt it onto the block and we torque it just like a cylinder head, and then they hone the block. Well, they bore it first with the torque plate off, then they hone it with the torque plate. So it's in a stressed position so that it makes it so when you bolt the head down, it's in a round circle. Does that make sense? Stuff like that people don't think about, but in a race car, it makes a difference because we want the piston to move as freely as possible.